from the University of Manchester, talking to us about data and macro development. Akos is a extremely accomplished macroeconomist, one of the experts in the world on structural transformation, and I have learned a ton from him about data, and also with his co-author, the late Bertolt Herrendorf. So we're very excited to have Akos talking to us today. And let me just give you a little bit of the ground rules here. Front row, please stay muted. You can ask clarifying questions. Akos plans to speak for about an hour and then take 15 minutes for discussion and questions. His collaborator, Patrick McNamara, is here, and he will be handling any questions that are entered into the Q&A. I guess that's it for the ground rules. We'll have a break next week in the course for Good Friday, but in 2 weeks, Todd Schulman will be talking about human capital data. So Akos, why don't you go ahead?
Thank you, Joe. So it's a pleasure for me to be here today and give this lecture on using macro data in development, with particular focus on using sector data, which well reflects the overall theme of the project, namely structural transformation and economic growth. So I'm going to break down my talk today into three. So I'm going to break down my talk today in three main sections, in addition to motivation and conclusion. Namely, I'm going to start with sector accounting for aggregate cross-country productivity differences. Next, I will discuss how to take data to multi-sector models using US time series. And finally, also using US time series and US data, I will discuss how multi-sector data can be dissected using input-output tables. So I selected few background papers. There's 5 papers from myself written with various co-authors. In particular, my late friend Bertolt is on all of this. And what I want to highlight the other papers on this list, namely the papers from Alder, Boppard, Müller, and then Boppard, and Komin, Lashkari, Mastieri, who these papers are about preferences on sectors, and the actual companion paper to the sector accounting is the last one, is Rastuccia paper in the GM in 2008. The paper of Greenwood, Herkovitz, Crossell is, in my mind, is one of the classic example, or one of the classic papers, how correctly or rightly take data to multi-sector growth models. And finally, the Incline, Marapin, Grela paper from the Groningen Growth and Development Center is one that describes and provides the first application of the data set, which I'm going to use in the sector accounting section of my lecture. Okay, so about motivation. So the aggregate, so the key question in macro development is why some countries are so much richer than others, and we use usually GDP per capita to measure the wealth of the nations. But today I will focus on productivity, and we know that GDP, that the employment to population ratio, although varies across countries quite a bit, it actually doesn't vary with GDP per capita. So in that sense, we can use interchangeably in analysis in general, GDP per capita versus GDP per worker. But why I'm focusing on GDP per worker is not just simply because I want to focus on productivity, but also in the sector context, you can't talk about sector per population. So the only thing you can talk about is how much employment is in a particular sector and how much they produce. So when we think about why some countries are so much richer than others, the one sector growth model provides us a natural framework to think about this. And in particular, it highlights that aggregate productivity gaps, by which I mean countries' labor productivities relative to the frontier, which in my case will be the United States, are a natural measure of the development level. Now, the Penwell tables, as was already discussed 2 weeks ago by Pete Clino in his lecture, offers PPPs that allows us to express aggregate productivity gaps at a common set of prices, which usually called international prices. So in that context, it's important to keep in mind that what the PPP does is converts domestic price quantities, which obviously different across countries, I mean the prices, into a common set of one. And then development accounting, which was the subject of the lecture 2 weeks ago, gives us key insight about the role of inputs and TFP in accounting for productivity differences. So this is all in thinking in the context of a one sector growth model. Now, the GDP per worker patterns are very similar to GDP per capita. Here, what we see is the GDP per worker relative to the US. On the horizontal axis is in 1960, and on the vertical axis, you see it's in 2017. And the red line is the 45-degree line. So any dots which is below the 45-degree line means that the productivity gap in 2017 is larger than it was 1960, and any country above the 45-degree line have smaller productivity gap in 2017 than 1960. So what the takeaway from this graph is, on the one hand, is a large dispersion of productivity levels across countries at the aggregate on the one hand. On the other hand, there's a lot of persistence. So countries going up and down on the productivity distribution across countries, but it's no tendency of convergence over time on a large set of countries. Now, the multi-sector growth model, which became more ubiquitous in the last 2 decades, provides a more nuanced view of productivity gaps. In particular, it makes us think about the potential fact that productivity gaps differ across sectors. Now, if productivity gaps differ across sectors, then we can naturally ask the question, which sector make poor countries so unproductive? But to answer that question, we need data to measure productivity gaps at the sector level. Now, once we did that measurement, we can obviously ask follow-up questions, namely, what drives the change of sectoral composition along the development path? So if productivity gaps at the sector level are different, then sectoral composition very much contributes to aggregate productivity differences. And if so, understanding what drives sector composition of the development path is potentially important, not just for us out of academic interest, but also for policy application. And any such exercise would require taking sector data to more multi-sector growth models. Okay, sector accounting. So let's have some basic concepts that we speak, let's say, the same language in some sense. So industries, what are industries? Industries are a collection of establishments that produce similar goods and services. So manufacturing is not manufacturing, let's say apparel is an industry, or farm is an industry, farms are in an industry. So establishment produce gross output from capital labor and intermediate inputs. And establishments then sell output to final users, other establishments, or themselves. So these are the industries. What are sectors, which will be my prominent use of term during this talk? Sectors are aggregates of industries with similar characteristics. So agriculture is a sector. Manufacturing is a sector. Business services is a sector. But below that, we have the industries. Now, the other two terms we have to be familiar what comes is, one is value added. Value added, value of gross output. So value added is value of gross output minus value of intermediate inputs. That's value added. So we can talk about industry value added, and naturally we can talk about sector value added. So what are final expenditure in contrast? Final expenditures are gross output delivered to final uses. So from that perspective, final expenditure actually are composite of value added from different sectors. Any piece of final expenditure, any consumption would be buy that comes from various large sections, so different sectors of the economy, and each includes some value added. So each piece of consumption would be buy includes a piece of value added in some part of the economy. This is why if I add up all the value added across sectors, I get a GDP, so the total final expenditure. Now, how to do exactly this link the sector value added to the final expenditure? That's what the input-output tables can do for us, that link gross output and value of sectors and industries to final expenditure categories. So getting this concept out of the way, so the 2 or 3 final concepts, just to make it precise, I already said, so productivity will be value added in international prices per worker. For short, I will use the same notation what Pete Clino used 2 weeks ago, namely, when I mean value added international prices, I'm just going to write PPP value added, or PPP GDP. Productivity gap is the productivity relative to the frontier productivity, and the frontier productivity today is in any sector and any year is the United States in that sector and in that year. Okay. So data issue. So measuring sector productivity is tricky. Why is it tricky? Because cross-country measurement of aggregate productivity is already tricky enough. So it's needed a lot of effort to put into the PEMVOL tables to provide us PPPs for GDP and for final expenditure categories. But those are only cover the expenditure side of the national income and product accounting, and they are at purchasers' prices. Okay. Now, the cross-country measurement of sector productivity, in contrast, would require sector value added from the production side of the NIPA and at producer prices. In addition, we would naturally need the sector PPPs to convert domestic prices into international prices. Now, sector PPPs were not available except for a small set of primarily rich countries. And the only exception was, which I will mention briefly, is agriculture, for which the FAO did such a measurement in the late 80s, early 90s. However, the cavalry arrived last year, October, from the Groningen Growth and Developments in the as a Groningen Growth and Development Center, because they published a new data set, what they call productivity level database. It was late October last year, for 84 countries, 18 from Africa, 21 Asia, 9 Latin America, 32 Europe. Is still Europe is the largest, although Europe also includes Eastern European countries, and the 4 Western offshoots. The Western offshoots are US, Canada, Australia, and New Zealand. Now, this data set covers about 88% of the world population. It differs a little bit in terms of various characteristics from the Penwell tables, which has 190 countries, I think. But still, it's a fairly representative. It includes 3 cross-sections, 2005, 2011, and 2017. The reason for these 3 years, because this is the so-called years for the benchmark years for the International Comparisons Program of the World Bank, which collects prices for a large set of countries, and the ICP also the basis of the Penwell tables. And this data set has 12 sectors: agriculture, mining, manufacturing, public utilities, construction, those are the goods, and trade, transport, business services, financial services, other services, real estate, and government services, these are the services. And the data set provides value added both at current prices and value added PPPs, which allows us to convert value added at the sector level at current prices into international prices. And it also provides employment. So it doesn't provide any aggregate, but I did aggregate following the proper index number construction into goods, services, and the aggregate. And what follows, I will present productivity gaps for agriculture and manufacturing. That's why they are highlighted in bold, and goods and services. The reason for agriculture and manufacturing, agriculture is one of the classic and the key sector in the context of development and structural transformation. Manufacturing, it's also is key, I think, in my view, in a context of discussion about industrialization. So this is the data set I will use for my cross-sectional data analysis. And let's add one more thing, which I think cannot be repeated too frequently in my view, is that the Groningen Growth and Development Center provides an enormous public good in general for all the data, typically macro data, accessible for free for everyone who wants to do research on various subjects. Okay, so I will proceed in 2 steps. First, I'm going to present a set of graphs which contrast the sector productivity gaps with the aggregate gap. That allows us to say, whether a particular sector, the productivity gap is smaller or larger than the aggregate. And then to gauge importance of the sector gaps for the aggregate, I will review the evidence how sectoral employment shares and value-added shares at domestic prices vary with the aggregate productivity gaps. This gives us a sense, particularly in terms of employment, because let's say if a sector is very unproductive, but very few people work there, but the employment share is very low, then it doesn't matter too much for aggregate productivity gaps, even if that's a low productivity sector. On the other hand, if the employment share of a particular sector is high, which actually also has very low productivity, then that matters a lot for the aggregate one. Okay, so let's have the first graph. So on the horizontal axis, we have the GDP per worker relative to the US. All the graphs are for 2017. And on the vertical axis, we have the PPP value added per worker relative to the US. And these are the 84 countries in this data set. And this is the agriculture productivity gap versus the aggregate. The red line is the 45-degree line. It means if the dot is below the red line, it means the productivity gap is larger in the agriculture than at the aggregate. If it's above, it means it's smaller, the productivity gap in agriculture than in the aggregate. So one takeaway from this graph, that except few rich countries in the very top, like Australia, Canada, I think Netherlands is also here, Argentina, New Zealand. Most of the countries, including many rich ones, the agriculture is less productive than the aggregate. In particular, as we go to the lower aggregate countries with lower aggregate productivity, what we see is the agricultural productivity gap is much larger than the aggregate. Moreover, we can also see when we look at the scale on the vertical axis that the gaps are really huge compared to the aggregate. So the aggregate gap per worker gap, except Malawi, is basically is large, but it's max factor of 32 relative to the US. So let's say poor countries, the poorest countries in this sample are 30 times less productive than the US. But if you look at agriculture, so we are talking about 64 times, or here's a bunch of countries, some of them like Botswana, who is actually doing very well at the aggregate level, the agriculture is a factor of 128 times less productive than the US. These are huge gaps compared to the aggregate. They're absolutely staggeringly large. So this graph, the first of this nature, was what was in the Casalis handbook chapter and also in the Restuccia paper. Both of them used the World Bank data. So that World Bank data was referred for the year 85, and the gaps in that data were smaller than this one. So they went up, they were still larger than aggregate, went up to 100, but they were less than these gaps. I mean, these are staggeringly large. I have to say that in some sense must have extremely important consequences for a range of development questions, which focus in particular the poorest countries on the planet. But let's look at now the manufacturing productivity gaps relative to aggregate. So the graph constructed in the same way as the previous one, namely on the horizontal axis, we see the aggregate productivity gap, GDP per worker, whereas on the vertical one, we see the value, PPP value per worker in manufacturing. First, the observation is that the productivity gaps are still in manufacturing are still larger than in aggregate. So typically, the typical country is actually below the 45-degree line with few exceptions. But there are countries in Africa, it's like Rwanda, Tanzania, Malawi, where the manufacturing productivity gap more or less the same as the aggregate. But probably the takeaway is that the manufacturing productivity gaps are still larger than the aggregate. However, they are smaller than in agriculture. Okay, so that's an important. So now, to be able to compare better, so I aggregated all the goods into one goods, and what we get is when we look at the productivity gaps for goods is it's beautifully below the 45-degree line, the red line, so that the suggesting that goods labor productivity gaps in goods are smaller, so the larger than the aggregate gaps. Consequently, it must be the case that the other part of the economy, namely service sector, the productivity gaps must be smaller than aggregate. And indeed, if we look at the productivity gaps in the services, what we see is that they are indeed above the 45-degree lines, typically, meaning that the productivity gaps in services are smaller than in the aggregate. I also would like to highlight that the actual scale, how much smaller they are. So even the least productive in our sample, Malawi, which has a aggregate productivity gap larger than factor of 32 relative to the US, it is less than half of that in the services, is factor of 16. Other African countries are even smaller. So also we may know that most of the rich countries, which, you know, the label's hard to distinguish, they're really bunching around 1. So they're very close, although above, but very close to the to 1. So this were the productivity gap, but as I said at the beginning, so they have some idea how the sector productivity gaps how important were the aggregate, and this is kind of more. This is my informal sector accounting, so I don't have these precise numbers. It's more like a visual representation. We have to look at the shares, employment shares in particular, but also value-added shares. So this is our next slide, and I go through the 4 sectors: agriculture, manufacturing, goods versus services. And let's start with agriculture. On the left panel, we have the agriculture employment share. On the right panel, we have the value-added share in domestic prices, calculated domestic prices. The horizontal axis, the shares are on the vertical axis in both cases, whereas the horizontal axis is the PPP GDP per worker relative to the US. So the first observation, which is well known, but still, when you produce the graph and look at it, it kind of feels staggering that the least productive countries are not only have the very, very unproductive agriculture, but they have most of their workforce employed in agriculture. And if you think about it, it of course makes sense because the agriculture is so unproductive and they need to produce food for the population. Of course, they have to work there. But still, one realizes that one of the key questions, which obviously has been known in the development literature, is one of the key questions is why agriculture is so unproductive in the poor countries, and why they have so many people employed there. If you look at the value-added share, what interesting takeaway, which again, those who like Dagolin or David Lagakos, who has papers on agriculture, they know very well what this graph means, that the value-added shares are much smaller of agriculture in many of the poor countries than employment share. It also means that also in the domestic economy, the non-agricultural sector is much more productive than the agricultural sector. And then naturally the question arises, and has been asked before, to what extent that's an implication of some misallocation in these countries. So if you look at manufacturing, it doesn't show such a sharp picture. It shows that both the employment shares and the value-added shares are relatively low. There are some differences. So the only thing which one can see one can see other graphs of similar nature, namely that it has a kind of hump-shaped pattern in these dots. Namely, poor countries have low value added and low employment in manufacturing, and it increases with the GDP per capita up to a point and declines again. So the last 2 graphs are about going to be goods and services. So here we see the classic patterns. So the employment share on the left-hand side, it's higher. I mean, the dots start higher than on the agriculture, but in the poor countries, most of this employment in goods that comes from agriculture. And as we move down, it's not only the goods are declining, but in general, but also agriculture declining. So many of these decline, what we see on the left-hand side goods, it comes from the decline of employment share in agriculture. So the value-added share, we see a similar decline. However, what is important, I will discuss a bit more in the next graph, is up until the aggregate product gap being a factor of 4, up until it almost looks like a flat line, the share of goods, which in the next slide, when I have the productivity, the employment share of services and value added, I start this time the value added, but it suggests that the share of services is, even the poorest countries, at least seems to be like 40% of total value added, which is GDP, or even higher. And it really starts going up sharply after the aggregate productivity gap reaches like the factor of 4. So the employment share, on the other hand, increases with income level very strikingly and strongly across countries. So the smaller productivity gaps relative to the US imply that higher is the employment share in services. Actually, in the US, the employment share of service around roughly 85% in 2017. So what are the takeaway from this brief sector accounting? So I did kind of came up with some averages. So the productivity gaps between the 9 and 10 percentile ratio. So it's not the US anymore, the 9 and the 10 percentile ratio. So the aggregate gap is a factor of 15. In agriculture, the factor 92. So it's huge compared to the aggregate. Manufacturing is a bit larger than the aggregate, but close to agriculture. The goods, again, the productivity gap between the 9 and 10 percentile is large, 35, but that primarily comes from agriculture. And services, it's just the productivity gap between 9 and 10 percentile. Productivity is actually only a factor of 7, so less than half of the aggregate one. So poor countries, as a summary, employ a large share of workers in the least productive sectors and produce a large share of the value in the least productive sector. And that is something which I think, to understand why that's the case and what are the drivers, or what are the forces that sustain this allocation of labor and output is not the only one of the key questions in macro development. Okay, so I move on to my next topic, namely macroeconomic data with multi-sector growth model. So the previous discussion of productivity gaps, I already said that we need to understand forces that drives reallocation. And we know from the existing literature on structural transformation that there's an interaction in multi-sector models between sector productivity changes and the structure of demand, which then reallocates the demand towards the services and away from agriculture. Such models can give us insights on these forces and including policy recommendations, potential policy insight, policy recommendations. However, there are complications when one uses multi-sector growth models. In particular, mapping models into data is more complex than mapping the one-sector model. And there are several reasons. So one is relative price movements. In a standard one-sector growth model, there is no relative price. Relative price is 1. In the multi-sector growth model, the key point is that relative sector productivities change, therefore relative prices change. They move over time. And also importantly, model GDP and data GDP are defined differently. And real quantities in the model are different from real quantities in the data. So understanding this nuanced difference between models and data is important when one takes the model to the data. And make, let's say, put more meat on the bone, I'm going to have a very simple model, multi-sector model, and I'm going to highlight the key points of this issue in these 4 points I said on the previous slide. So the simplest multi-sector growth model is just the two-sector growth model, which has been used, for example, in the Greenwood-Herkovitz-Rosell paper 97. Namely, we have only consumption and investment as a standard model, but in context of the one-sector case, these produced with two different technologies, and the only tiny bit which they differ is the productivity terms, because both technologies are Cobb-Douglas with the same factor shares, but the productivities are different. So consumption is AC and AX is in the sector producing investment goods. The utility is simply log. So the growth factor are defined by this hat, which is the growth of the growth factor of the sector TFPs. And we have a feasibility constant or capital labor is important. Labor is normalized to 1, and we have the capital accumulation. And it's very easy to solve. The household problem gives us the Euler equation, where we already have the relative prices appearing, okay, which usually we don't in a standard one-sector model. And that firm first order condition tells us that the relative price moves of investment relative to consumption moves inverse how the relative productivities move. And we know that empirically the investment prices are falling. Hence, the relevant assumption which we will make here is that productivity in the investment sector is growing faster than the consumption sector. Okay. So one more slide on the model before going to the data is that the first order condition implied that the capital labor ratios equalize across sectors. And since we normalized the labor equal 1, the aggregate capital labor ratio is just a capital. And the sector production functions can always write in that the sector capital labor ratio can be substituted out with the aggregate 1. Okay. And then the expenditure ratios in this simple model, so consumption expenditure, investment expenditure is going to be equal to the labor hour, the ratio of consumption to investment. Okay. Now, production side aggregation. So one is the GDP in this model, which casually we usually say Y. Here we have two Ys. We have YC and YX, depending which numerator you choose when you solve your model. For real allocation, it doesn't matter. Choice of numerator doesn't matter for anything a macro theorist would be interested in. But when it comes to data, taking things to the data, the numerator does matter. You will see in a minute. So the capital PX will be the price of investment relative to consumption, and a capital PC will be the price of consumption relative to investment. And this is the two GDPs. And similarly, we can actually aggregate the production function. Either the aggregate GDP is equal to units of consumption with the capital times the consumption TFP with this Cobb-Douglas aggregation, and the same or similar or the equivalent for the GDP expressed in units of investment. And the same holds for wages as well. This could be in consumption or in in investment units. Again, what I like to emphasize that for the real quantities, the choice of numerator doesn't matter in the model, the real quantities in the model, like C or X. But it does matter when we take into the data. Why? Because if we use numeraire to define GDP, then this is kind of very much similar. We can derive a GDP growth from the model, simply dividing by yt plus 1 to yt, but it does, or t minus 1, but it does depend on which numerator I have chosen. But in the data, at least in the US, I'm going to use the US data definition. Yeah, the GDP growth is not defined this way. It defined with the Fisher quantity index, which is the geometric average of the last pair and Pasch indices. So we can't just simply look at national income and product accounts, take a GDP growth rate and say, well, let's quantify our model using that growth rate. So if I look at the actual data between 1947 and 2018, I can calculate GDP, real GDP in units of investment. How? Well, one had to deflate the nominal GDP with the investment deflator. Then we get GDP in investment units, the Fisher index. We can also divide it by the consumption unit. Importantly, we get different growth rates. So the average growth rate would be investment units is the highest, the lowest is the consumption units, and the Fisher index is in between. And there's a plenty of reason why the Fisher index should be used, and that's the reason why it is used. And my discussion is about to be aware of these differences between data in the quantities in the data versus quantities in the model. So just a brief discussion that when we calculated investment, we included consumer durables and into investment and used the service flow from consumer durables. You added it to consumption. If you look at time series wise, then the dashed line is the numerator investment GDP per worker in the US, 1947 normalized to 1. The solid line is the Fisher, and the dotted line is the numerator consumption. It's quite clear that both the Fisher index and numerator consumption shows a market slowdown in terms of growth rate, but the numerator investment doesn't. Or, well, at least for the naked eye, doesn't. And it's also worth to note that this is what happened to relative prices during this period. So the price of consumption relative to investment rose quite a bit, and a factor of 2.5 during this period. So, what is the implication? The implication is how to connect model with the data, that construct a balanced growth space in the model using numerator investment, then construct the model GDP by applying the Fisher index to the balanced growth space quantities, and then connect the model GDP calculated this way to NIPA GDP. Now, this can generalize to any multi-sector growth model, not just to consumption investment. And since all models of structural transformation have multi-sector, this principle applies also to those models. So because the time is short, I'm going to skip one slide. And I just want to say that if I use this two-sector model, and I do this exercise, what I suggested one should do, this is how my data and model looks like. My data and model doesn't coincide, but they don't miss each other too much either. So The solid line is the data GDP per worker with the Fisher index, and the dashed line is the one where I use the model consumption and investment quantities, where the numerator was the investment price to construct with the Fisher index the model GDP, and this is how they compare. Okay. So my final, in the next 30 minutes, I will discuss the structural change both in consumption and investment. And this is where my discussion about input-output tables and the relation to the multi-sector model comes into this. And this is a crucial aspect of a national products account, as we learn in actually Econ 101 to a very basic extent, namely that national income accounts is more than one account. And in particular, there are expenditure accounts and their production account, their income account. They don't make sharp distinction between production and income account here. So the big difference is really between expenditure and production. Namely, when I look at the expenditure side of NIPA, which we typically or most frequently do, we see detailed information about final expenditure categories: consumption, investment, government consumption, exports and imports. But we see no information about production factors. We don't know what production factor was used to produce this consumption, but how much capital, how much labor was used to produce. We know how much capital and labor was used to produce GDP because that's the aggregate. So we know aggregate capital and aggregate labor, but no information specifically assigned to either consumption or investment in terms of production function. Now, on the other hand, if you look at the production side of NIPA, so that's where we have all sectors, we have information about sector output, the production factor assigned to those sectors, particularly labor. That's typically available for a large set of countries. Capital, less so. One can use various trickeries to distribute aggregate capital across sectors, which I don't want to get into it. But importantly, we have no information about financial expenditure categories. If I look at manufacturing, I don't know what computer was sold for investment and what computer was sold to household for consumption. And the problem is that when I build a model, a multi-sector model, we need naturally the model, the production side, and also the expenditure side simultaneously. But how exactly we connect them, it's not obvious, just looking at the data. Now, the two sides of the GDP or national accounts connected by the input-output structure, or more precisely, in terms of the national income and product account, is with the input-output tables. And the US publishes now, I mean now meaning I think since 2018, they reconstructed back annual input-output tables since 1947. And initially it was 46 industries, but now are more than 65 industries. And but writing down a model with fully fledged input-output structure is actually kind of cumbersome. It actually might be an overkill for a lot of questions. I can think of questions where input-output structure is very important to write down explicitly, but not all questions. And many of the questions, important questions, we don't need it, but we still need to model the economy in a consistent way. So, and this is where we can use the input-output tables, the data one from in this. If I use US data, I would use naturally I use the US input-output tables, that we can break down final expenditure into their sectoral value-added components. The particular bit of the input-output tables is called total requirement matrix, or the theoretical name is the Leontief inverse, which does this mapping from expenditures into value added. And that allows us to have sector value added representation of final expenditures. And that sector representation of final expenditures can be then combined with sector production factors. So the only thing therefore I can then write down sector production functions as value added production function, and then the value that is sold either for investment or for consumption. And I broke down the data that way, so I can bring in the data to discipline my model or quantify my model. So to have a better idea, let's do some examples from the US data. So the one type of preferences we can estimate on US data, what's called the Stone-Geary preferences. It's a non-homothetic preferences of consumption. It's just over two type of goods versus services. And there's this bar term which makes these preferences are non-homothetic, and which implies the demand for goods in terms of expenditure shares, which is the standard way to estimate demand functions. And for two goods, there's always enough n-1 equations to estimate all the parameters. So in this case, there's one is enough, but E is the total expenditures in current price, and E are in per capita terms, okay, per capita expenditures. So if we estimate these preferences on final consumption expenditures, so this is the expenditure side of GDP, we get a very good fit with non-homothetic preferences. With this, so the CS bar term is significantly larger than 0. And we also get that the elasticity of substitution parameter, while sigma C is, strictly speaking, for Stone-Geary is not elasticity of substitution, but close to link to that. And we get a very good fit. And this is the expenditure side, but we can also do, when we break down final consumption expenditure into value added and goods value added share and sector value added share, we get also a very good fit. I will discuss the differences that for value added, it seems the elasticity of substitution parameter is smaller, so kind of it appears to be more complement when we do this breakdown. So the reason is the way you can think about it is why in the value-added case it's more complementary than in the final expenditure case, is that think of the cotton shirt, which in a final expenditure you buy in a retail store, and that's your final expenditure. But in the value-added case, so on the right-hand side, what is happening is that the shirt, the value added from agriculture and manufacturing, that is in goods, but the wholesale and the retail part of those margins are in services. And since the same good you are interested in are broken into two different categories, that kind of makes it more complementary across the two categories than in a final expenditure case. So, but the same thing I can do with nominal with investment expenditures, namely, so I write down a value-added production function for goods and services, and it sells value-added both for consumption and investment purposes. And then investment then combines it with the CS aggregator, the goods and the services, into one investment. Okay. And then, but to be able to quantify this, first one needs to construct SG and XS from the data. That's what we do with the input-output tables, and then estimate this object on the data. And here, so on the one hand, what's important, and here the estimation implies that these are perfect complements in this particular case, namely that, perfect complements. So I think almost final slide is before my concluding remark is the comparison of final investment expenditure and final consumption expenditure. These are both value-added shares, so these are comparable. So they are both outcome of taking investment expenditures and then using input-output or consumption expenditures using input-output tables to construct the value added generated by investment expenditure and consumption expenditure. So one key takeaway is that this structural change happens not only within consumption, which you see on the right-hand side, but also ongoing within investment. So investment comprises more and more services relative to than goods. Compare, like in the 50s, it was like 65% of the investment were goods related to goods sectors, but now is less than 50% related. It has a multitude of factors. It includes that R&D expenditures are capitalized, so intangible capital has been increasing, and that's primarily generated by expenditure on various investment expenditure on various service value added, such as R&D, but also it's related to various other services like software and IT-related services, which also capitalized. However, what I also like to emphasize that investment is still much more good intensive than consumption. And that actually is relevant, so meaning that the omegas, the omega C, which measures the weight of goods in the preferences for consumption and in technology for investment, it's smaller. And the relevance of that is that because of changes in relative prices during this period in the US, namely the solid line is the price of services relative to goods has been going up, and while price of goods relative to investment is more or less constant. But in contrast, the price of service relative to investment is going up. That it means that the relative price of consumption going up faster because it uses less and less goods and more services, which is going up faster relative to goods. It happens in services as well, but services are still much behind. And that actually generates this increase of price of consumption relative to the US. Okay. So in conclusion, and that's where I end, sector productivity gaps are large. That's the first part of the lecture. Good sector gaps tend to be larger and service gaps smaller than the aggregate gap, and poor countries employ a large share of their workforce in unproductive sectors. And agriculture is one of the key unproductive sectors in poor countries. So taking data multi-sector model is more complex than taking them to one sector model. When solve multi-sector model, we choose a numeraire, and official statistics don't use numeraire, and that's one of the key aspects one has to pay attention to. And reallocation is driven both by income effect and price effect and structural transformation, structural change happening both in consumption and investment as an economy is growing. Thank you.
Wonderful. Thank you, Akos. We had a very active Q&A inside the Q&A window and also among the panelists. Let me throw out the first question just briefly, because there were multiple questions on both sides about this distinction between value added and gross output. Why you start with value added rather than gross output. Yeah, could you address that? Obviously, you have a famous paper in the AER that I tried to reference, but
okay. So I don't know, Patrick, whether you did answer any questions. So shall I just start what is in the Q&A part? Oh, no, you answered.
Oh, no, I was talking about...
you answered the one. So the first time I used this one, so that's why I have to ask qualifying.
Okay. No, could you answer?
So the question I see is the one you didn't answer, Patrick. Am I right?
So he says,
I don't hear anything.
Yeah, no, he's asking something that's not, that you won't be able to see in the Q&A right now.
Sorry.
Yeah. So there were multiple questions about why you use value added rather than gross output, and why value added should be the measure of productivity.
So I haven't, sorry, I have to.
Guess you can't hear me.
Just one more minute. I think because
No, we can hear you, Joe.
No one has spoken my.
I don't think Akos can.
Okay, no, I hear no, because I haven't spoken. No one have spoken. My speaker switched off. Sorry, Patrick, I didn't understand. Didn't understand what you said. Could you repeat it, please?
So Joe can summarize. Yeah,
there were multiple questions, both among the panelists and in the Q&A, about why it's important to use value added, and why you use value added when the production function doesn't have materials in it, and why do you use value added rather than gross output when calculating productivity. And obviously you've written an important paper in the AER exactly on this distinction, so I want to give you a chance to answer.
Okay, so there are data issues versus okay, so I start with the data issue. There is no gross output available. The answer is as simple as that. It's hard enough to get value-added data available. So for these 84 countries, there will be gross output available, but not yet. I mean, the Groningen guys haven't released that particular part of the data yet. That's number one. But they will, one could. But the issue is that productivity won't be comparable with anything else, in the sense of we always have GDP per worker as aggregate productivity. I couldn't do this comparison between aggregate versus sector. So that's in terms of comparability, we always use value added in this analysis. So that's number one. I think I just stick to the data issue.
Okay,
and
Patrick, I know you had mentioned there was a question that you couldn't answer, that you asked somebody to bring up.
Yeah, so there's one question that was in the chat. Let me see here. What would make the productivity gap in services lower than the productivity gap in manufacturing? And does the productivity level database include informal industries within manufacturing?
Yes. Informal to the extent it's possible. You know, it's called informal because we don't even know for sure how big it is. But to the extent that the various surveys, both official and, well, official meaning surveys which go into the published regular statistics, plus the other surveys which don't, but available for use, the Groningen guys include those data into when they construct this data. So I can't speak exactly how much is included or not, but when I'm reading their data description, where they break it down by countries, they do a lot of work to include particular employment, the self-employed and informal workers into the statistics. So there are statistics about it. It is just, for example, censuses have information, quite good one about that, which then they use to correct the data, scale them up, scale them accordingly. So I would say, in a summary, to the extent you can include the informal and self-employed data into this data, to the extent they included.
We'll take some questions from the people in the front row, the panelists. If you want to raise your hand, then I'll call on you. The first is Changchen Gu.
Hi, thanks for your presentation. It was very interesting. My question is centered on the value added of the agricultural product. I noticed there are countries like Australia, Argentina, New Zealand, the value added of the agricultural product is above the 45-degree line. But in the historic time series, these economies we classified as a commodity exporting economy. So most of the price of the agricultural products are driven by global demand. So when there's a high global demand, you will see a higher price on the agricultural products. So my question is, if we actually use the product price of these agricultural products during the commodity price boom period, are you worried that the productivity of these sectors will be overestimated?
I mean, yeah. I mean, when we think of agriculture, okay, so on one hand is what you have to think about it in a way is that all prices are averaged across countries. Sure, since agricultural products like, let's say, cocoa, what we use for chocolate. So that price is when they do this calculation is the same across countries, but some countries don't produce it, and very few do. And when those prices are high, yes, there could be overvalued. But I don't think actually Australia, New Zealand, and those countries are overvalued because of that. I mean, their agriculture, or Argentina, they are much more. To some extent, yes, I'm not denying it, but it's more that the agriculture is more efficient, more productive. If you look at the average farm size in Australia, the average farm size in Malawi is less than 1 hectare. How can you possibly, do any efficient production there? I mean, I think even if there's commodity prices can distort a little bit, I think the bulk of the productivity difference comes from actual efficiency or the TFP, if you like, and not the commodity prices.
Batu, do you want to ask your question? Good to see you, by the way.
Yes, hi Joe, hi Coach. Thank you so much for the lecture. I have a question concerning the GDP in the model and the issue with the numerator. So essentially, if in the model I'm more interested in even in the data too, in value added, sectoral value added, and mostly sectoral value added shares. Does the issue still hold when I look at sectoral value added shares in the model? I mean, the issue with the numerator. And in that case, like, how can we basically mitigate the issue? Because you gave the example of GDP using the Fisher index, but I don't know if that would still apply with value added. And also then my other question would be like, is it really a good idea to consider value added shares instead of GDP shares in the model?
Hey, Akos, let's take one more question, and that's probably the last question. And you can handle them both together. Vivek.
Yeah, so I'm sorry, I have two questions. One is
Okay.
regarding one is regarding the productivity differences across sectors. So what do you think are the reasons for these productivity differences? Are they more due to a selection similar to Melit's kind of selection where a selection happens, then there's a cutoff difference across countries, or do you think the frontiers in different countries are different to begin with? And another question is regarding the Piggle preferences for structural transformation. Do they also have the same pitfalls which you mentioned with respect to income and price movements?
Mhm.
Yeah, thank you for that.
Okay. So the value-added shares in the model versus data. So the value-added shares are perfectly okay. I mean, those are equivalent in the model in the data. So the model, we have everything in numeraire, and more to that, it is in the current numeraire, the numeraire of that period. That means is the so-called multi-sector model, the real thing is as close as possible to nominal one, with the exception of the way you can think of it is the overall inflation is removed, but all the cross-sectoral things are there. So what that means is that is like if you calculate a value-added share, is like you take out both the numerator and denominator, the same kind of price thing. So the actual share is the same. So this is why the using value-added shares from the data and just putting them in the model, that's perfectly fine. There's no problem there. It's the real quantities in the model versus the data. So that's where the issues really are. So productive differences across sectors. Yeah, I think that's a big question. So what is it? Selection, David has a paper some years ago in AER in terms of agriculture and the difference. So why the agriculture productivity within countries, so that what's called agriculture productivity gap is so large, namely that the same currency, agriculture is so less productive a worker than in non-agriculture. And what their conclusion was in the paper, that yes, selection plays a role, but I don't think we know enough about that. I'm pretty sure that misallocation is also an important. If you think about land regulations in many poorer countries, for historical, political, social, so whatever reason, I mean, I knew that farm sizes are smaller, but less than 1 hectare, the average farm size, it's just impossible to. I tell you one example. It's just really just to have a picture. Once a friend of mine visited.
It's got to be a quick example though, because we're out
Very
of
quick
time.
example, and even in the context, so how big difference it makes. Visited Ukraine well before this war and everything. Just visited agriculture, and he said, the guy gets into the machine at the beginning of the shift and drives straight ahead for 8 hours until end of the shift, and that's where the field ends. You know how much productivity you lose that you have to turn the machine several times a day because your field is too short? Now just imagine that it's in a hectare. So that's one. Okay. So the other question was productivity. You asked another question of one is this differences across for the selection.
Yeah.
Second question.
The other question is on the structural transformation, the utility function. It's about the Piggle utility function, Piggle preferences, the PIGL, and.
No, I mean so you can estimate the parameter. That is no problem there. There is one. Okay, there is one though. So when you have that aggregate data, you don't have prices, you have a price index, where the price index is normalized to 1 in 1 year or 100 in 1 year. Now, for example, in the Stone Geary, that constant, the bar term, that changes which year you normalize to 1. The sigma remains the same, it doesn't matter. And of course, it makes sense why the C bar changes depending to which year you normalize the price index. Why? Because the C bar is a kind of a real quantity there. So if you use different price index, the C bar going to change. But this is just really a small technical thing. It doesn't really affect any of the results of the model, even if quantitative results.
Okay. Unfortunately, it's a great discussion. Unfortunately, it has to come to a close because of it's late in some places, and especially Despina, who is helping with this. It's late in London, so on a Friday. So thank you very much. I don't know if we can unmute and give the awful way you give a round of applause on Zoom, but I think we ought to for Akos because he did a wonderful job. Akos, there are some other people that had questions. I suspect you'd be okay with them emailing you.
Yeah, sure. No, please feel free to email. When it comes to my research, I'm happy to answer questions.
And I'm sorry that we couldn't get to them all.
All area of structural change and data and so on.
But thank you very much. And in 2 weeks, I think David will be back with you hosting. It could be Doug, but I think it's David. And Todd Schulman will be talking about human capital data.